Hello everyone, welcome to this course on block volume and local NVMe storage. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this module, we will look into the use cases for local and block storage. We'll describe the OCI block volume service and its various capabilities, and then we'll do a quick demo and walk through the block volumes and its features. Before we get started with the block volume and the local NVMe services, let's quickly look at the various characteristics of these two storage solutions. So the local NVMe storage is NVMe SSD based temporary storage, and as the name specifies, it's non-persistent, it's temporary, but it survives reboots. The capacity can be in terabytes plus, and right here you can see the various sizes we support today. So if you are using a bare metal instance, we support sizes of up to 51 terabyte. If you are using virtual machines, we have various sizes going from 6.4 terabytes to 25.6 terabyte. That's a lot of storage volume. So if you're running workloads like big data, OLTP workloads, any kind of high performance workloads, HPC scenarios, local NVMe storage is a good fit, especially if you're concerned about performance and price performance. On the other hand, we also support block volumes, and these are NVMe SSD based as well, but these are block storage, meaning they are not directly attached to the instance. So they're not the direct attached storage, but they are the network storage. They live somewhere on the network and not directly attached to the compute instances. Because of that, they have much higher durabilities. And to give you this, because this is a managed service, we manage multiple copies within a single AD, and we'll look into how backup and restore works for block volumes. The capacity is much higher, it can be in petabytes, and as you can see here some of the numbers, the block volume service supports volume sizes going from 50 gigs to 32 terabyte per volume. So a single volume can be up to 32 terabyte in size, and you can attach 32 volumes, up to 32 volumes for every instance. So if you do the math, 32 volumes into 32 terabyte each, the maximum size, you end up with a 1 petabyte storage solution for your compute instances. That's just insane. That's a very big number. Now the use case for block volumes are applications that require SAN, your on-prem SAN-like features. So these can be your database applications. If you're running any kind of application which makes use of a high performance database, you could use block volumes. If you're running ESXi, you have VMware workloads, your virtualized workloads, you could use them. If you're running SharePoint, Exchange, those kind of workloads, block volume is a good candidate for those kind of workloads. Before we get into the block volume service, let's look into the local NVMe SSD devices. Some instance shapes in OCI include locally attached NVMe devices. We covered this in our earlier course on the compute service. Local NVMe SSD can be used for workloads that have high storage performance requirements. So whether it's HPC workloads, big data workloads, data warehouse workloads, you could use NVMe SSD devices. Keep in mind that the locally attached SSDs are not protected, and OCI provides no RAID, snapshot, backup capabilities for these devices, and so you as customers are responsible for the durability of data on the local SSDs. And right here you can see the various configurations we support today. So if you are using a bare metal instance Gen 2, we have a shape which has 51 terabyte of raw local NVMe SSD storage. If you are using virtual machines, we have different configurations available here. And I'm just showing an example here. If I do a list of all my block devices, I can see my local SSD disks here, and if you do the math, comes out to close to 51.2 terabyte. Now, one thing I said in the beginning is that these are temporary storage, but they survive reboot. So what do I mean by that? So what I mean with this is if you're running our instance, whether it's a virtual machine or a bare metal instance, and you have local NVMe SSD, the data is saved on the instance if you reboot or pause the instance. And there's a nice quote here from Accenture, which says that with OCI, customers can leverage NVMe for persistent storage to host database and applications, but with other cloud providers, typically we don't get this capabilities. It was not persistent. That means that the multi-terabyte database that Accenture folks were using was lost when the servers stopped in case of other cloud providers. So in those scenarios, the data deleted on instance reboot or pause. So if you have a use case like that where you have to reboot your instance because let's say you are patching your database, for example, just keep in mind that even though it's a temporary storage, the data is persistent for reboots and pauses. Now we said that Oracle doesn't provide any RAID configuration, doesn't provide any backup. So you are responsible for managing and maintaining the durability of these devices, because if you're running, let's say, a database application, you want that data to be durable and persistent, right? So how can you do that? Now there are various mechanisms you could use to protect these devices. The simplest one is a RAID 1 configuration, where you have an exact copy or a mirror of a set of data on 2 or more disks as shown here. It's a very simple RAID mechanism, something which customers use all the time. There's also something which is a little bit more complex called RAID 1 plus 0, also called RAID 10, where you combine mirroring with striping. So RAID 10 stripes data across multiple mirrored pairs. As long as one disk in each mirrored pair is functional, data can still be retrieved. So it's a much better, if you're concerned about getting better durability, go with RAID 1 plus 0. There's also something called RAID 6. Now RAID 6 gives you block level striping with 2 parity blocks distributed across all member disks. What it means is you can lose 2 drives and still not lose any data. The issue with RAID 6 versus a RAID 10 is that in case of RAID 6, there is an extra checksum, so the writes are much slower compared to RAID 10. So if you are really concerned about the performance, go with RAID 10. This has a good trade-off of performance and durability. RAID 6 gives you higher durability, but there is some in cases where you are writing a lot, your performance might suffer. So there are various options available, and you can again go read up documentation. Setting up RAID configuration is very straightforward, and this is a mechanism we recommend to protect your local NVMe SSD devices. Now for these devices, we really feel good about their performance, so we offer a service level agreement. Keep in mind, we are the only cloud provider who actually provides an SLA for performance, period. There is no SLA for performance anywhere else in the public cloud space. So as you can see here, first of all, with the various shapes, we have a minimum supported IOPS number. Now this number in many cases is more than what is being shown here, but this is the minimum supported IOPS. So you can see that with a dense IO bare metal instance, we support a minimum of 3 million IOPS. Now these IOPS are 4K block sizes with 100% random write workloads. And there you can run your own benchmarks. We have worked with a third-party company to do a bunch of these benchmarks available on this GitHub link here. So you could actually download the test suite and you could run your own set of benchmark tests. But keep in mind that we do have an SLA for local NVMe performance. Now let's change gears and talk about the block volume service. So block volume service lets you store data on block volumes independently and beyond the lifespan of compute instances. Block volumes operate at the raw storage device level and manage data as a set of numbered, fixed size blocks using a protocol such as iSCSI. You can create, attach, connect and move volumes as needed to meet your storage and application requirements. The typical scenarios for block volume: persistent and durable storage. Now this is in contrast to the local NVMe storage, which is non-persistent. Of course it survives reboots but still non-persistent. Block volume is persistent, and block volume is network storage. So you are storing your blocks, your data on the network. It's completely separate from your compute instance. It's not locally attached, direct attached storage. The other scenario you would use block volume service today is to expand an instance's storage. And we'll look into that. And you would also use it for instance scaling. We'll look into that. If you have to change the shape of your instance, go from 1 core to 24 core for example, you would use block volume to do that. For the various characteristics of the service, you can see the various sizes we support, going from 50 gig to 32 terabyte. We looked into it at the beginning of this course. It's all NVMe SSD based. We have a baseline IOPS per gig of 60 IOPS per gig, and for every volume we support up to 25,000 IOPS, and these IO blocks are 256 KB block sizes. There is a throughput number here, and the latency is in sub-millisecond latencies. For a particular instance you can attach up to 32 volumes per instance, and if you do the math you can get up to 1 petabyte of storage per instance. Because this storage is durable and persistent, we manage multiple replicas across multiple storage servers within the availability domain. So first thing to keep in mind is block volume is an AD specific service. It runs, the block volumes, they themselves reside in a data center in an AD, and they run on a network. They are network storage, so they run on storage servers which live somewhere on the network, and we manage multiple copies. So if something one of the copies get corrupted, we still have other copies, and we can guarantee that the data is available to you. The data is encrypted both at rest and also in transit. So how do you create and attach a block volume? It's a pretty straightforward process. We'll go and look into this in the demo. You specify the name, you specify your AD in your data center where it lives, and you specify the size, and you have a bunch of other options you specify, and you create a block volume. Once you create a block volume, you have to attach it to the compute instances so that you can start using them in your applications and you can start storing your data there. There are two mechanisms which you could use to attach your block volume. The first is called paravirtualized. Paravirtualization is a light virtualization technique where a virtual machine utilizes hypervisor APIs to access remote storage directly as if it were a local device, and we'll look into this in the demo. The other option is iSCSI, and iSCSI block storage attachment utilizes the internal storage stack in the guest OS and network hardware virtualization to access block volumes. In this case, hypervisor is not involved when you work with the iSCSI attachment. As you can guess, if you are going with the bare metal option, you would use iSCSI. Paravirtualization actually has a dependency on the hypervisor. So for VMs you could use both. For bare metal you would probably use iSCSI. You can also when you attach your volumes, you could choose between read and write or read only. So if you want to prevent any kind of accidental modification, just go with read only mode. There is also something called CHAP credentials. CHAP stands for Challenge Handshake Authentication Protocol, and if you click this option here, CHAP credentials, iSCSI uses this security protocol to communicate between the volume and the instance. So if you're concerned about a higher level of security, go with CHAP credentials and you can leverage that feature. Now we looked at how you create and attach a volume. How do you detach and delete a block volume? It's when an instance no longer requires a block volume, you can disconnect and detach it from the instance without any loss of data. When you attach the same volume to another instance or to the same instance, just keep in mind that do not format the disk volume. If you run fdisk option, you would lose all the data on the volume. When the volume is not needed, you can delete the block volume. Once you delete it, it's permanently deleted. As I said, we make 3 copies, but when you delete it, we delete all the copies. So so keep in mind that if you delete it, there is no sort of an archive option where you can archive the old volumes. It's really straightforward. You can click detach here. This block volume is running for attached to an instance, and you can detach it and then you can delete it. Now there are a couple of features which are very interesting and relevant for block volumes. They include backup, restoration, cloning, and volume groups, and we'll cover all of these in the next few slides. The first thing is backup and restoration. So backup is nothing but a complete point in time snapshot copy of your block volumes. So let's say you are running an compute instance here. This is in my AD1. As you can see, this is my region. I have my virtual cloud network. Typically we have 3 in every region. We have 3 ADs. So typically we show all ADs in the diagram. In this case, just to keep things simple, I'm showing 2 ADs. Let's say you have a compute instance running and you have a block storage here, a block volume here. What you could do is you could create a backup of this block volume, and the backup actually goes and is stored in object storage. It's encrypted and stored in the object storage service, and the advantage is you can restore from this backup any new volumes to any AD within the same region. So my backup is stored here, but let's say I want to create this for HA purposes or DR purposes. I want to create the same application and leverage my existing data in another AD. So it's very simple. If we have the backup enabled, I can just go here in object storage and I can restore from there as a new volume in my AD2, and my application would still be up and running. So this is how the backup and restoration works. There are various options for backup. There is on-demand one-off backup. So anytime you can come in and you can do create a backup of your block volumes. There is automated policy-based backups. These are backups which are created automatically on a scheduled and retained based on a selected backup policy. There are 3 backup policies today. The first one is the bronze, where we take monthly incremental backups which are retained for 12 months, and the full year backup is retained for 5 years. There is silver backup, where we have weekly incremental backups retained for 4 weeks, and of course you also get the bronze as part of the silver backup policy. And the last one, and the one which is the most extensive, is the gold, where we do daily incremental backups retained for 7 days plus silver plus bronze. So if you're really concerned about very mission critical data, go with the gold backup policy. It's something which is the most extensive, and you can retain all your data for much longer period at a much finer granularity. Now when you do an on-demand one-off block volume backups, you have a choice of incremental, versus a full backup options. A full backup meaning you take the full backup of the volume. It doesn't matter what previous backups were there. If you go with an incremental backup, the system is smart enough to look at the last backup, has a pointer, and then it only takes the backup of the data which has changed since the last backup. So you have an option, you could do that, and the reason you would do it is for the cost purposes, because when you are storing backups in object storage, you're paying for that. So you don't want to do a full backup every time. You can always go with incremental backups. You can restore a volume in less than a minute regardless of the volume size, even if the volume is something around 32 terabytes. Now there is also a feature called cloning. Cloning allows copying an entire existing block volume to a new volume without needing to go through a backup and restore process. So what do I mean from that? It means that clone is a point in time direct disk to disk copy. So what it means is disk to disk copy means that we are no longer going to object storage and restoring from there. In the previous slide we saw, if I go back a couple of slides, we saw that the backup process, the backup is actually taken to the object storage, and you restore from this object storage to another AD. You could create a new volume, or the same AD you could restore here as well. You actually involve an object storage in between. Now in case of cloning, you actually don't do that, because cloning is a direct disk to disk copy of an entire volume. So as you can guess, you can clone in the same AD, cannot clone across ADs. The clone operation is immediate, but the actual copy of data happens in the background and can take up to 15 minutes for a 1 terabyte volume. So there's a trade-off there, and like I said, clone can only be created in the same AD with no need of detaching the source volume before cloning it. And you can see, once you're taking the clone, the lifecycle state changes from provisioning to available within seconds. But the data it's called lazy copying. It happens in the background, and the data gets copied in the background, but the volume available within seconds. There's also a feature called volume groups, and the idea here is you can group together block and boot volumes from multiple compartments across multiple instances in a volume group. So this simplifies the process of creating backups and clones and restoring them. So think about a typical enterprise application has multiple tiers. So let's say there is a web tier, there is an app tier, and there is a database tier, right? Now each of these tiers has block volumes. You can see a bunch of block volumes here. Some of them also might have boot volumes, right? You're running these compute instances so they will have boot volumes. So what you could do is you could take all these volumes together, you group them together, and then you could operate on them as a single unit. This makes your life much easier, because if you have to take the backup of an application, you can take the backup of all these volumes simultaneously in one go. You don't have to do them manually one by one, right? This is again a unique feature. No one else provides this feature, but only Oracle Cloud Infrastructure. You can use volume groups to create volume group backups and clones that are point in time and crash consistent. And you can manually trigger a full or incremental backup of all the volumes in a volume group, leveraging a coordinated snapshot across all the volumes. And we will look into the volume groups. We'll cover that in our demo. We looked into the boot volumes as part of our compute course. Compute instance is launched using an operating system image, which is stored on a remote boot volume. So boot volume is nothing but a special type of a block volume. Boot volume is created automatically and associated with an instance until you terminate the instance. Boot volumes, like block volumes, are encrypted. They have fast performance, lower launch times. They're using all the NVMe SSD storage underneath. Compute instance can be scaled to a larger shape by using boot volumes. So you preserve the boot volumes and then you can change the shape. You can go to a higher shape. You can preserve the boot volume when you terminate a compute instance. Boot volumes are only terminated when you manually delete them. If you don't delete them, they stay in your account, and like I said earlier, boot volumes cannot be detached from a running instance. Because it's a special type of block volume, you can do a manual backup, you can assign a backup policy, or you could create a clone of a boot volume, because it's type of a block volume, and these features are all available with block volumes. You can also create custom boot volumes which have your the size you specify, and right here you can see the default sizes we support for Linux is 46.6 gig, for Windows is 256 gig, but you can always have your own custom boot volume size, which can be much larger than these sizes here. There is also something called block volume offline resize, and the OCI block volume service lets you expand the size of block volumes and boot volumes. You have three options today to increase the size of your volumes. The first is expanding an existing volume in place with offline resizing. So how does that work? First thing you do is you stop your instance, you detach your boot or block volumes, you expand the boot and the block volume. So for example, let's say they were 100 gig in size. You could go to 1 terabyte or 32 terabyte. You could expand your boot or block volumes. Then you reattach them to your instances. You restart the instance, and then you extend the partition so the guest operating system recognizes the increased size. And you can see here it's the graphic is showing that, right? You can also restore from a volume backup to a larger volume. So when you do backups and you are trying to restore from the backup, you're not limited to just the size of your original backup. So original backup was 100 gig, you could literally restore to 32 terabyte. And same thing when you do cloning. Earlier both backup and cloning were limited to only the size of the original backup or the clone, but now similar to backups, when you clone and you can clone to a new larger volume. Just keep in mind that you can increase the size of the volume, but today you cannot decrease the size. So that's design consideration you should keep in mind. So with that, we covered a lot of ground. We looked at some unique features like policy-based backup, which is only provided by Oracle Cloud Infrastructure. We looked at volume groups, again a feature which is only offered by Oracle Cloud Infrastructure. So let's look at the block volume demo. Here I am logged into my Oracle Cloud Infrastructure console, OCI console, and if I click on the left hand side, I can see block storage service and the various options which are available here. So I'll click on block volume storage service, and I can see that couple of storage volumes I had created earlier. Now let me go and create a new volume from scratch. So we are using this compartment called training for all our level 100 foundational training courses. So I would use the same compartment. I need to provide a name for my block volume. So I would say, let's say this is my block volume 1. And then it asks me to pick an availability domain, because keep in mind that block volumes are specific, AD specific, right? So I'll pick my AD1 here, and it's asking me for a size. So I would say 100 gig is fine. And right here I can assign a backup policy. So I could choose no backup policy. I could go with bronze, monthly, silver, weekly, gold, daily backups. I could do that. So let's go with a gold backup. That's the most extensive. This is a critical data I want to protect. So let's do that. Now right here I can provide a key value pair. I can do tagging, or I could also encrypt this volume using key management. Now keep in mind that the OCI block volume service provides server side encryption both in transit as well as at rest, but those are the keys we provide. Now if you want to use your own encryption keys, you could use the key management capability here. So you could provide your vault here, and you could provide your own master encryption key, and we will encrypt your volume using your own keys. If you choose not to do that, we will anyways encrypt the volume, but the keys will be Oracle provided, not customer provided. I will have a course. I have a course later on where we talk about key management. So for now, let's just skip it and create this block volume. Now the block volume will be up and running in a few seconds, and once it's running, I would go and attach it to my compute instance. Now in the compute course, we spun up a bunch of instances, and I have those instances running here. I have a bare metal machine 52 core running here, and I have a virtual machine VM with 8 cores running here as well. So if I click on this, I can see that there is no block volume which is attached to this compute instance. So let me just go and SSH into this instance. I'll bring up my git bash and SSH into this instance. Okay. SSH OPC. I can see here that I'm logged on to my instance. Now if I do a list of all the block devices, I can see that there are no block volumes which are attached here. Everything is boot volume here. I can see the 46.6 gig boot volume here, right? So first thing I'm going to do is I'm going to attach my block volume. Now when I do that, it's giving me the two options. Either I can go with iSCSI or I can go with paravirtualized. These are the two options which we looked earlier in our slides. So I would choose iSCSI, and right here it's the drop down gives me the list of all the block volumes available in this AD. Remember, my compute instance and the block volumes have to be the same AD for the block volume to be attached to the compute instance. So in AD1 I have the block volume 1 we just created available. So I choose that read write is okay for me as an access for this block volume, and right here I could choose to use CHAP credentials, challenge handshake authentication protocol, the security protocol for iSCSI to communicate between the instance and the volumes. I've decided not to use it right now, and I'll just click attach here. Now as it's attached, it gives me this message which says that when you do this, run the iSCSI commands using the OS tools to log in and enable the block volume. Now note that if you choose to add this volume to the fstab file where you will keep a list of all your volumes, you must include the _net dev and no fail options. Failure to do so will cause the instance to fail to boot in the future. So that's just keep in mind. The reason it's added here is we saw a bunch of customers who were missing this step. So it's always a good reminder to follow these steps. Now I can come here. I can see that my drive is volume is attached. It's iSCSI. It's attached in the read write mode. It's 100 gig in size, and right here I can come and I can see some of the iSCSI commands. Now I see some of the iSCSI attach commands, and I can see detach commands. I can see the IP address and port. This is my storage server where my block volume is running, and this is my iSCSI qualified name. So it goes, the fully qualified name here, the port, long string. Remember, this is the place where my storage server is, where my block volume is residing. But again, these things are abstracted. You really don't have to be concerned about those. I'll just copy the iSCSI commands, and using my git bash prompt here, let me run these commands. And as I do that, let me clear the screen. Now if I do the list of block devices, now you can see that I have a block device of 100 gig available here. Now to make this useful, I can come and format this disk, right? So this is, I'm just starting right now, so there is nothing on this disk, but I could format this disk. To make it useful, I need to create a file system on top of this volume. So I would say create a ext4 file system, and my volume is located here /dev/sdb, and when I say that, use the whole partition, right? It's fine. And now let me just mount it so I can use as my disk. So I'll say I'll create a mount point here, sudo, and let me just mount. And now if I do my let me just clear the screen, I can see that I have a disk 1 available at this mount point, 100 gig in size, and now I can start using this disk to write data. Either I'm using an application, or if I'm taking a backup or something, I could start using this disk from there. Now few things to keep in mind. I can come here, I can detach this instance, this volume from the instance, and if I do that, remember I need to run these detach commands on my instance as well, inside my guest operating system. I could there are a bunch of other features I could use. So if I go back to my block volume, I can create a backup of that block volume. So let me just log in to my console. I can create a backup of my block volumes. I can create a clone of my block volume. So I could say create backup, and I could give my first or I would say backup 1, and it's that simple. I just create that, and my backup is now getting created. I could create a clone as well. Now these two operations cannot run simultaneously, so if we say block volume 1 clone 1, it would give me an error saying a backup is going on. There's a backup operation in progress. So as soon as the backup is done, I can do a clone. Now when I do the clone, I could do a custom size as well, right? So we looked into this earlier. My actual was 100 gig in size. I could actually create a clone of this volume and have it around half a terabyte, 500 gigs. So I could do that. Let me just see if my backup is done. Backup is still going on, and you can see the backup size is small because I really don't have data here, and it says it's a manual because I just triggered it. It's not automated, policy based, and it's a full backup. So now I can come to the clone, and I create a clone of this volume, clone 1, and I can say a custom size. Let me go to 200 gig, and I can also encrypt this using key management. And now my clone is created, and this clone is the size is 200 gig. It's not 100 gig anymore, right? So I could actually change the size when I do the backup and backups. Now I create on this volume groups here, and I had a volume group created earlier. I was testing this feature. I'll say create volume group, and I need to provide a name here. So I would say let's say volume group 2, and it says which are the volumes which are there. So I would say where is the volume group to be created. So I would say create it 81, and then it says pick a volume. So I would say block volume 1, for my 81, and then it says pick another volume, and actually I have a couple of boot volumes here. So I'll pick the boot volume for this volume group, and I would create a volume group here. My volume group here, you can see it has a block volume 1, right, and it also has a boot volume, right? So it makes life much simpler for me. Now if I can come to volume group backups, I could create a backup here, and I could say this is my volume group 2 backup 1, and now what it would do is it would create a backup of both the block volumes as well as the boot volumes. So again, if you have a complex application which has many block volumes, boot volumes, volume groups make life much easier. If you don't have a feature like this, you have to go and manually script the backup and restore and cloning, etc. So that's pretty much everything on block storage. Let me see, we have the block volume backups which appear here. We took a backup, it's it's appearing here. The volume group backups appear here. We took a volume group backup right now. You can see number of backups, etc. It's getting created here. That's pretty much everything on block volumes. So let's go back to the slides. And the final thing here is on the pricing. You can see the price is based on a gigabyte of storage per month, and this is the price we charge for block volumes. And if you compare again this pricing with pricing from, let's say, Amazon, because we don't charge for IOPS, our pricing is much cheaper. So if you have a 400 gig storage, the price on OCI is something like $17 per month with 25,000 IOPS. If you have to get the same IOPS on Amazon, because you are paying for those IOPS, the cost would be something like $1,350. So it's insanely cheaper than Amazon. Just keep in mind, we don't charge for IOPS, but we do give you consistent IOPS per gig, and that's the number you can see here, 60 IOPS, which is actually higher than what you get with Amazon EBS, which is only 50 IOPS per gig. So to summarize, OCI offers local NVMe SSD storage. We saw earlier with SLAs. The use case is high performance workloads. The block volume service is persistent, durable, high performance block service with industry leading price performance. You just saw some of the price performance numbers. You can create, attach, connect, move volumes as needed to meet your storage and application requirements. Block volume supports backups. You could do on demand, full backups, incremental backups. We also support policy based automated backups. No other cloud provider does that. We have a policy based backup as well. We also have this capability called cloning, where you can clone. It's a direct disk to disk copy. Again, this is a feature which no one else provides except Oracle Cloud Infrastructure. And there is the third unique feature called volume groups, which simplifies the backups of running enterprise applications that span multiple storage volumes across multiple instances. So with that, thanks for attending this course on local NVMe storage as well as the block volume service. I hope this was really useful, and I look forward to seeing you in the next storage services courses.